All right, I can get started because I definitely have a full 30 minutes of stuff to talk about. So I appreciate you showing up, and I hope to respect your time by giving you a lot of information that you can use, hopefully to go build robots, right? So the BeagleBone Black, which is, I've got an Altoids tin around here somewhere. So the BeagleBone Black, oh, that's not it. It's inside here, right? So the BeagleBone Black is a 1 gigahertz Linux computer. It's open hardware. And it's stuck right now, but so it's a gigahertz computer that runs Linux desktop operating system, but it's open hardware, so you can fully customize it. And we've done some things that I think to try to make it really easy to use, and it has some hardware features that make it really special for making robots. I'll show you some of that today, but there's a lot of different things going on. So what I really recommend is that you check out the BeagleBone.org website and join the community, right? So we have a big mailing list of people that are interacting with each other. We usually have 200 or 300 people on our live chat IRC channel. So I really recommend that you get engaged with the community and talk to other people about what they're doing. And that's the place where you're really going to learn. But I want to try to give you a kind of a shotgun view of like some of all the crazy fun things that are going on around building robots. So these are some examples. So I've got the Beagle MIP with me today. You can take the same thing and build a Beagle Quad. I'll talk to you a little bit more about some of the example robots, but there are tons and tons of them. Well, if you're building a robot, first, like, what is it that you really want a robot to do? And a lot of these things that you want a robot to do, you can just handle with a microcontroller, right? And sometimes using a microcontroller solution, like a launch pad or Arduino, is really the right way to go about building your robot. But when you want to do some smarter things, or you want to do some things that take a lot of CPU cycles, things that want to use some, maybe I want to not just program in C or Arduino sketches, maybe I want to program in Python or Ruby or JavaScript. That's okay? Okay. You know, when I wanted to program with some of these higher level languages, or maybe I wanted to talk to my Wi-Fi tablet, or talk to it over a web page, or do some other things with it, right? So that's when you start thinking about using one of these Linux single board computers or something, you know, a computer within your robot. So you want to do things like be able to sense the world around you. You want to be able to do rangefinders. You want to be able to control motors. You want to be able to do all those things. And so the BeagleBone Black is really special because it allows you to do both of those things. It allows you to do all the computer things. You're talking to the web, talking to the internet. You're talking to high-level languages and doing really high performance processing, and also do the really low-level stuff where you're talking to the individual sensors and stuff that you're learning about, like with other systems. So it's an open hardware computer for makers. Everything that you need to get started with the BeagleBone is in the box, right? So it's just a board and a USB cable. That's really all you need, because it comes with all the software that you need to actually get started programming, and includes a tutorial environment to learn how to start doing some electronic stuff, right? How to do some sort of basic physical world interaction with electronics. So it's already programmed. You don't have to go and get, you know, first step, you don't have to go download some software or anything like that, because it's already on the board. So when you plug it in over the USB cable, you're ready to start going, and you can get up and running in just 5 minutes. And there's a huge ecosystem of people doing things with the BeagleBone Black, from all sorts of crazy fun projects. I've seen about 20 different projects around the show, and I know I haven't seen anywhere close to all of them. So you'll see BeagleBones being used all over the show, and we've got a list of some of them at the booth with some flyers, so you can find some of those. And then and we have a lot of people actually going and putting them into real products. And sometimes you'll find some of the things that people are building around here where they'll be buried underneath and you won't even know they're there. Another thing that makes a BeagleBone kind of special is this thing called a cape. So the add-on boards for it kind of have that little bit of a shape where they're kind of a cut around the Ethernet jack. And you can stack up to 4 of those, and they can work up together as long as they don't interfere with any of the resources. But I talked about having a lot of I/O, and what you need to make a robot is a lot of I/O, a lot of connections, because you want to control a lot of things on your robot. You want to detect a bunch of different things if it's running into things in different directions, or you have all the different types of sensors, where there's a lot of ways to hook up all those things to the BeagleBone, and it's through these expansion headers, right? So the things that you see on the side of the board, and so there are things like UARTs and I2C and SPI, and there are great ways to find out the details of those. But the nice way to just start is to go find some online documentation where there's a wiring diagram and just wire it up and just start using it. So you don't have to understand all the details of all these interfaces before you can get started. And then some people avoid you having to learn how to hook up these things at all. So there's a company, Tygel, that actually makes this thing called a microbus cape. And it's one that has just modular things. So you don't have to figure out how you go and wire up all these little buses. You can just go by that and just have little simple plugins. Okay, so what type of things are people really doing with the BeagleBone Black, right? So how many of you have heard of OpenRob? Okay, quite a few of it. So those of you who haven't, you really need to go check them out because they're doing some really, really cool stuff. All right, so these guys wanted to go out and explore caves. And the equipment that it took to go and do this, they wanted to explore underwater caves and find lost treasures and gold. And the equipment to do that was really expensive, so they decided they would build their own. And they built an entire community around this underwater exploration, right? And now they've got these kits. They built an entire business out of it. And it's a really fantastic device. And they put a BeagleBone in there. So what they do is they actually control the BeagleBone through their laptop, and it's got a network connection. And in their web browser, they can actually see what the BeagleBone sees, right? So they hook up a little USB webcam to it, and it all just streams back into their browser, and they can control it. And then they send signals back down to tell it to go which way, left and right, and they can explore the oceans with this. And then there's this thing, the Beagle MIP, right? So this is a, oh, I gotta turn the motor on, that would help. There's this thing called a Beagle MIP, and I busted it. Of course I busted it. It got a little damage in shipping here. It's actually a really nice, robust robot if I didn't crack the gears. Should have tested that first. But this is a self-balancing robot. So they've got an Addon board, a cape here that has an inertial measurement unit that tells it know when if it's leaning back and forth one way or the other. And they have a program that detects that, and it automatically adjusts the wheels in order to keep it standing upright. And it's got sensors on here called quadrature encoders, so it actually knows how far the wheels are turning, and it's using the hardware on the board for doing that. And they can take the same thing and actually build things like quadcopters out of it, right? So you just plug in the motor cord, so you have 4 motors, and you can make it fly, and you can still use the same balancing algorithms. And then they've got their cape that they've got, so it's open hardware that you can go and get to actually build your robots with. But this is kind of abstract for people, right? If you're just getting started with building robots, you really want to understand what's going on, kind of underneath the covers. Like buying a finished board like this might be too much for you. You might not really learn everything that you'd want out of that. So Georgia Tech did a massively open online course on building mobile robots, and they've provided the design materials, and they've left that course online on Coursera, and they tell you how to build a robot off of a BeagleBone using components from SparkFun. So they've got a nice little this plastic case, the Redbot, and then you've got the motors and the wheels and everything. And they show you how to wire stuff up. So I'm actually going to show you how some of the components for that are wired up. I just want to kind of to break down again. So again, why is a BeagleBone really nice for this? It's because it has a lot of IOs, 65 digital IOs, 7 analog inputs, 8 pulse width modulators. It's also got these things called PRUs. So though you have both that main processor that's running Linux, that's talking to the internet, communicating across systems, allowing you to run Python and JavaScript. But you can put the real-time tasks on these microcontrollers so that they can go and access the pins and do the things that you need to actually happen in real time. Because a lot of you are using Linux, right? So Linux by default is not what you call a real-time operating system. When you actually say something in Linux, Linux tries to be really efficient in I/O, and that means like gathering up a bunch of work to do all at once, which means that the way it's scheduling is not really predictable. So something may happen really quick one time, and it may not happen for a long time and other times. And you're probably really used to that in the computers. You need that sort of experience in computers. Well, if you're building a robot, that's simply just not acceptable, right? You have to have something happen when it needed to happen. So putting a lot of the real-time tasks on these microcontrollers is really a nice way to go about doing that. Got a fast processor, Linux make networking easy, ready to use out of the box. So how are people going and creating these things? And I just want to make sure you see some of these words. You kind of can walk out with a little bit of an impression of these different programming languages, because there's a lot of them out there. And people are using all of these programming languages to create robots with BeagleBones. So you can find people doing things in just about anything that you're already familiar with. So if you already know something, bring that to the BeagleBone, go about it that way. If you don't, I recommend getting started with Python or JavaScript as a nice introductory to programming languages, and then learning about those microcontrollers and how to do those in C or assembly later on. So like get your circuits working, kind of figure out how to do all the basic electronic stuff, and figure out some of the hard programming tasks later, right? So start with your scripting languages, figure out if you've got the electronics right, and then move on. I've heard really great things about Go. Go is a fairly new programming language. I think Google is kind of the big pusher behind Go, but it's got some performance advantages, and there's some really great libraries for building robots on Go. There's one called a GoBot. You can look up gobot.io, and they support programming in Go on the BeagleBone Black. Of course, we've got Oracle over here. You could use Java. So the Oracle Java just runs just fine on the BeagleBone Black. There's Ruby, which a lot of people like for beginning robot development, or just beginning programming in general. So there's a library called R2, A-R-T-O-O, that you can use to program robots in Ruby. Some people use Erlang. Forth, you can even program those the PRUs in Forth. So there's a Forth compiler that you can go and get for those PRUs. Lisp, Perl, Python, JavaScript, and there's also visual programming languages like Scratch or Blockly that you can run. Professional visual programming languages like LabVIEW or Simulink, and also eToys, which is on top of the Squeak. So that's like a huge world, all these different programming languages that you can possibly go to create your robots in, right? And then when you get down, it's like, okay, well, I just want to look at JavaScript and Python. Then there's a huge different set of different libraries and different approaches that I can take with just those, right? So I've written a library in JavaScript called BoneScript that gives you some basic I/O functions, lets you to control the pins, a little bit in an Arduino-like syntax where it's digital read, digital write. How many of you have programmed Arduino? Awesome, awesome. How many of you have programmed launchpads? Anybody? So the launch pads are really nice as well. So you can program in the same sort of familiar environments you do there. But the fact that a lot of you are already familiar with doing stuff with microcontrollers is absolutely fantastic. And that really tells me that you're kind of ready to make that jump. Because if you've already done that programming on microcontrollers, it's going to really prepare you for jumping into something like this. Johnny 5 is a JavaScript library that a lot of people use in conjunction with either a computer or maybe like a Raspberry Pi along with an Arduino. And it's interesting, you can do the same thing on a BeagleBone, but there's really not that much of a need to it. So you can run Johnny 5 on a BeagleBone to talk to an Arduino, Or you can just actually do this stuff on the BeagleBone because it's got the microcontrollers, right? So you don't have to go and buy that extra hardware in order to do that real-time communications, or to read that analog sensor, or to drive that you need that pulse width modulator to control the servo motor, or to control the speed of your DC motor. The hardware is actually there. So you may not necessarily want something like Johnny 5, but maybe eventually they'll provide support for BeagleBone natively. But currently, if you use Johnny 5 on a BeagleBone, it's to talk to some sort of external microcontroller. And then there's a really nice one that I like I'll try to show some examples on, which is Cylon. So Cylon.js is a robotics building framework. They have a similar framework in Ruby called R2, and one in Go called Go.io. So Cylon.js is their one, and they've got a lot of different peripherals. It's just standard libraries for connecting up to devices, and they support the BeagleBone Black natively, so you can actually use a lot of the interfaces, and that library is evolving very quickly. And then IBM has developed something called Node-RED. And a lot of people wouldn't necessarily think about Node-RED as being something for building robots, because they talk about it as being an Internet of Things language. But it runs on Node.js, so it's a JavaScript implementation. But it provides a graphical environment, and I'll show that running on the BeagleBone as well. There's another one called this thing called BotSpeak. So BotSpeak there's a JavaScript implementation that runs on the BeagleBone Black of this, and it's an interpreter. And the nice thing about it is it allows you to there's different interfaces that are done for it, for something like LabVIEW. So how many of you have heard of First Robotics? So not that many of you even heard of it. It's a really great program. It teaches high school kids how to build robots, and they compete. It's a really great encouragement for education. So I highly encourage you to check out US First and First Robotics. But those guys get started with a tool called LabVIEW. And so if you want to take those skills that you've learned in First and apply them to programming the BeagleBone, you can actually use LabVIEW and this BotSpeak interpreter, and it'll actually allow you to create programs in LabVIEW to run on the BeagleBone. And then for Python, there are two big key libraries for just doing kind of basic I/O. These are fairly similar to like my BoneScript library in JavaScript. But there's the Adafruit BBIO, and then there's PyBBIO. So the Adafruit BBIO is, they try to maintain a lot of compatibility with what they have for the Raspberry Pi. So if you're programming in Python on the Raspberry Pi and you're doing some of the I/O functions, and you just need a lot more I/O, or you need more performance, you can maintain a lot of that compatibility by using that Adafruit BBIO library. And then the PyBBIO tries to get more power out of the BeagleBone, right? It's more focused on a BeagleBone specific Python library. And then one of the nice things about working in Python is you can work with OpenCV. So OpenCV is a computer vision library. So it allows you to do something like hook up a web camera, do face detection, do other object recognition. I've done some simple things where I can take up the web camera and I track like a red ball or something. It's really easy to detect. And so you can roll the red ball around and have your robot follow the ball. Or you can have it look at your face and follow your face. We were showing one of those last year that was just following your face around. So Python has really nice bindings to this OpenCV library. It allows you to do a lot of vision applications with your robot. So let's look at how to actually wire some of this stuff up. So I've got some of the components of building up a robot up on my board. Unfortunately, I ended up burning out some things and tearing up my motor, so my motor doesn't even connect up anymore. But I've got my servo motor on here, and so you can connect up things like wireless sensors. You can see the wiring is not overly complicated for that. So you connect up things like wireless sensors. I've got a potentiometer here connected up on my board, so I can use that as control. I've got a button to act as a digital sensor that you could also use things like collision detection with digital buttons. And I've connected up a servo motor, and just show that. So looking specifically at the servo motor, so this is essentially all you need in order to kind of drive a servo motor. a small servo motor with the BeagleBone Black, because here we're pulling directly off the 5-volt power off the USB cable that I'm running on my laptop. So it's not going to be a super powerful drive off of that. And you just need to put in a resistor in line to use one of the signals that's P2M capable, and then use a resistor to protect the output pin. So if we, I'm going to flip over here and run my program here in the background. Did I not get the camera? Which one's the... There we go. So you can see here, I'm controlling the servo motor by turning the potentiometer and moving the servo motor with the BeagleBone Black. So I'm doing this with the BoneScript library, and so this is the integrated development environment that ships with the BeagleBone. So when you plug in the cable, the BeagleBone is already running a web server, and you just point your browser here to the board, and there you can type in your programs and click run. You also have a terminal window down below where you can run Linux commands. And this is, if you've used the previous BeagleBone, you'll notice that the new version of the Cloud 980 is much slicker. But the thing to remember here is that this is actually being served up and being run on the board. I'm just using my web browser to act as an interface to it, right? So I don't need to go and install any extra tools. I'm just using my standard Chrome web browser. And this is the code that I'm running. That's the DC motor. It's not servo, it's server. So I bring in my BoneScript library. I set the pin. I'm going to try to roll that up a bit. I set the pin that I'm going to be driving. I set up a few parameters that I'm going to use to set what I want to set up as duty cycle out to my servo motor, and I simply do an analog write in order to actually drive my servo motor. So that's how I turn on the PWM. So here I'm setting the duty cycle and setting the pulse cycle to 60 hertz. And then I'm going to read back here the potentiometer, and then if I didn't get any errors, then I'm going to actually set the value of the position to be based on where I had that potentiometer. And then after 40 milliseconds, I'm going to go back and redo the whole thing. So this is kind of basically what it looks like in JavaScript. And if I wanted to do the same thing with Cylon, so Cylon, their website has a bunch of different examples on it. So Cylon.js. And if you can scroll down to the bottom, you'll see information about the different platforms they support, including BeagleBone Black. And if you see some of the different sensors that they have, like servo, not the repo. Sorry, I wanted to look at the example. So here you bring in the Cylon library. Of course, you need to replace this with BeagleBone. So the name is a BeagleBone, the adapter is BeagleBone, and you don't need a port because it's actually native on the board. And you can do the same thing. This is how you would essentially drive a servo, right? So you do my.servo and set the angle where you want the servo motor to be. So this is a little bit higher level of abstraction, right? So you saw with the BoneScript library, there was one where you're just saying drive the PWM, at this frequency, at this rate, at this duty cycle and this frequency. Here they have abstraction layers that allow you to say, okay, I'm just having a servo motor. What pin did I hook it up to? And now I can start sending some other commands. And if I want to do the same thing in Node-RED, I'd actually have to end up using the BoneScript library, because what Node-RED does is actually something quite different. So this is Node-RED running on the BeagleBone, so it's actually being served up. So you would install Node-RED using their instructions. I don't have that example here, but you actually have to end up programming in BoneScript using one of their function blocks. So you can open up one of the function blocks, and you can put in the code here to process data upon the message. So you can get a message from one of your analog input pins, and you make it all as kind of a wiring diagram. So I just want to close, that's sort of my basic example. But I want to close by saying that there's a bunch of books to help you get started. So Matt Richardson has written one called Getting Started with BeagleBone. Simon Monk, who I believe is over at the McGraw-Hill booth as well, has written a book on using BoneScript. So you can go and contact him or go buy his book. And then there are books specifically on BeagleBone robotics projects. So you can check those out. And if you have any other questions, I'm going to be at this the BeagleBoard.org booth right after this talk. So if we can kind of clear out for the next speaker and go hide out over there, we can answer any of your questions that you might have on BeagleBone. Okay.